Hello everyone and welcome to my presentation on binary trees in data structures. I'm presenting along with my group members Yadav Surendra Pratap, Satyam Pandey and Abhishek Raj. Let's begin. So let's get started with what a binary tree actually is. A binary tree is a special type of tree used to represent hierarchical relationships and perform efficient searching and sorting. A binary tree is a hierarchical data structure in which each node has at most two children, a left child and a right child. Alright, moving forward towards terminology. Before we dive deeper, let's understand some important terms in binary trees. Node, element of the tree containing data. You can imagine it as a small box holding information. Then comes the root, the topmost node of the tree. This is the starting point for all connections. Then moving forward to parent and child. This describes the relationship between connected nodes. If one node is linked to another below it, the upper is the parent and the lower is the child. Leaf node, a node with no children, like the last stops in the tree's branches. Height of the tree, the number of edges in the longest path from the root to a leaf. Then comes the depth, the distance from the root to a specific node. Subtree, any node along with all its descendants. Moving forward to the next slide. Properties of binary tree. Some key properties include maximum children. Each node can have 0, 1 or 2 children. Unique root. This is exactly one root node in every binary tree. Level of a node. This is the distance from the root. Then height of a tree, the maximum level of any node in the tree. Internal node, a node with at least one child. Leaf node, a node with no children. In other words, these properties define the overall shape and structure of a binary tree, telling us how nodes are arranged and how we measure their positions. There are several types of binary tree. Full binary tree. Every node has either 0 or 2 children. No node had just one child. Complete binary tree, all levels are completely filled except possibly the last, which is filled from left to right. Perfect binary tree, all internal nodes have two children and all nodes are at the same level. Degenerate or pathological tree, every parent node has one child, making it look like a linked tree. Balanced binary tree, the height difference between the left and the right subtrees of any node is at most 1. These types matter because they affect performance. Some trees are very efficient for searching, while others can become slow if they are not balanced.
We know about traversal techniques. First, in order, second, pre-order, and third, post-order. First, in order, left node right, the sort is LNR. Second, pre-order, node left right, the sort is NLR. And the third, post-order, left right node, the sort is LRN. We can see the example of in order, post order, and pre order. First, in order. Visit the left subtree. First, visit the root node and visit the right subtree. Example like K, Z, L, H, D, B, E, A, I, F, M, J, C, and how we use in a binary search tree. In order gives nodes in sorted order. Second is post order. First visit the left subtree, second visit the right subtree, and third visit the root nodes Example K Z L H D B E A I F M J C. How useful for deleting and freeing nodes of a tree, child nodes before parents. And the third is pre-order traversal. First, visit the root nodes. Second, visit the left subtree. And the third, visit the right subtree. Example K Z L H D B E A I F M J C. And how useful for creating a copy of the tree or saving tree structure.
Now, like any data structure, binary trees have their advantages and disadvantages. Let's talk about their advantages first. They allow faster searching, insertion, and deletion compared to arrays, especially in balanced trees. They are ideal for representing hierarchical relationships. Now, the disadvantages are the implementation is more complex than arrays. If the tree becomes unbalanced, performance can degrade significantly. To conclude, binary trees are a fundamental tool in computer science. They make data management more efficient, especially when we understand their types, properties, and transversal methods. Balanced trees ensure optimal performance, making them valuable in many applications. That brings us to the end of our presentation. On behalf of my team, I would like to thank our faculty, classmates, and all of you for listening patiently and giving us this opportunity to share our work on binary tree. Thank you.